So good afternoon, sir. Sir, please unmute yourself, sir. You are in mute.
Yeah, good afternoon, madam.
Good afternoon, sir. Deepti, are you?
Yes, ma'am.
Shall we start? Please start, ma'am.
A warm welcome to respected dignitaries and faculty members. I extend my hearty welcome to each and everyone. Myself, Sridipti, pursuing third year from the Department of Tripoli from SV Colleges. Welcome to the short-term training program on research trends in renewable photovoltaic system and its research challenges. Before going to the session, there are some rules to follow. I request everyone to please mute your microphone and turn off your video. And please post your queries in the chat box. Thank you. Now, I take the pleasure of inviting a man of distinction and a fountainhead of illuminating ideas, Dr. K. Sudhi sir, HOD of Tripoli Department. Welcome, sir.
Deepti, you continue, ma'am. You just continue.
Yes. I consider it a great honor to speak about our chief guest, Dr. J. Srinivasulu Garu. He is presently working as a senior assistant professor in training placement officer at JNTUA College of Engineering, Anantapur. He has completed his BTech in MITS Madanapalli, MTech in JNTUA College of Engineering, Anantapur, and PhD in JNTU University, Anantapur. He has total 11 years, 6 months teaching experience. He has published 50 national and international journals and presented 4 national and international conferences. His research interest areas are electrical power systems, restructured power systems, and power system reliability. As a coordinator, he has conducted 11 workshops or trainings and attended 34 workshops. He has also conducted 3 guest lectures and delivered 1 guest lecture. He acted as 8 times as judge for technical symposiums. He has served various administrative positions like training and placement officer, coordinator of career and counseling cell, students coordinator, and nodal officer. He is a member in IEEE and IAENG. Now, I would like to hand over the session to Dr. J. Srinivasulu Garu. Welcome, sir.
Thank you, Deepti, for introducing me to the audience.
Thank you, sir.
Shall we start, sir?
Yes, madam. Just I'm sharing my screen. Then I will start.
Okay, sir. Okay, sir. Okay, sir.
Madam, are you able to see my screen?
Yes, sir. Yes, sir. It's visible, sir.
Yes, thank you. Thank you. I hope my screen and my audio is visible and audible, right?
Yes, sir. It's clear and.
Yeah, thank you. Thank you. Well, good afternoon to all of you. Well, in today's class, I want to discuss about and I want to make you make aware about a smart grid and its benefits and its challenges. We all know that a few decades back, our traditional power system was a vertically integrated power system, and later, with many engineers' efforts and their efforts and their contribution, power system was renamed as restructured power systems, and also it is named as deregulated power systems. So the drawback of electrical power system, traditional electrical power system, is monopolism is there, and as well as direct access with the generation system is not possible for any customer, and even prices customer generator charging customer with high prices whenever demand is high. So, and even whenever energy generation is not sufficient to meet the demand, then also they can raise to, then also they can raise the prices, such that based on all these uh, drawbacks, engineers thought to reshape the power system with by creating good competition in the system, and such that more number of people will be involved in electrical power system, and they can do business, and they can even with electrical energy also. So that's why they changed the structure of the power system, and that's why it is named as restructured power systems. Well, based on that platform, due to advancement of technology, even in power industry and even in digital process also, due to advancement of technology in power industry as well as a digital communication system. Hence, from restructure to power system for improving efficiency and as well as reliability and reliable operations in power systems will be possible by making use advanced technology, especially like digital communication equipments. So based on that, uh, we have electric grid, and that will be smarter. So how an electric grid, what is the traditional electric grid and what is the smart grid, and how smart grid will give benefits to the customers, to the market participants, to the generators, and for all entities, organizations who are take part in the market operations. So yes, coming to the electric grid. So, what is the electric grid? So, an electric grid is nothing but a network of synchronized power providers and consumers, and that are connected by transmission and distribution lines and operated with a control centers. So, that is nothing but electric grid. So, electric grid is nothing but network of synchronized power providers and consumers through transmission and distribution lines with control centers. So just you see the power system layout here I presented. So generating station, and with generating step up transformer, and the generated energy will be step up to a higher values like 138 kilovolts, 230 kilovolts, or up to 765 kilovolts, and that will be transmitted. And why we need, I hope you all know that what is the importance of step up here. So it is mainly for reducing losses, and that's why we are going to step up the voltage levels such that I square R losses will be reduced, nothing but copper losses. So, and later that high amount of voltage values is not possible to utilize for our daily life applications. Hence, we need to step down that voltage to a normal values at substation by using step down transformer. And to a value like 26 kilovolts or 69 kilovolts. And there onwards, distribution system will be starts, and like primary distribution system and as well as secondary distribution system, and different what you call different consumers like industrial consumers, commercial consumers, and domestic consumers will be take part in the distribution system. So the industrial customers may tap electrical energy at the substation itself, uh, and few small scale industries may tap electrical energy from primary distribution system, and for commercial and residential customers may tap energy from secondary distribution system. So this is the traditional grid, and how the performance of the grid will be varies. So based on what factors the performance of the grid will be varies. So basically we all know that every day population is increasing and such that demand for electricity is also increases. So whenever demand for electricity increases, hence the performance of the grid will be varies. So that is one of the prime factor to affect the performance of existing grid. And not only that one, due to increasing of demand, definitely available supply is not able to meet the demand. Hence, performance will be varies. Nothing but supply shortfalls of electricity and need of reducing. So, if you reduce the losses, then also performance of the system grid will be changes. Even peak demand management. When you during peak demand, when you apply some management strategies, techniques to reduce the peak demand, then also performance will be varies. And even integration of renewable energy generation. So nowadays, uh, not only India, everywhere more importance is given by the people for integrating renewable energy generation. So that means why it means with renewable energy generation, more number of advantages are there. Why? Because non-renewable energy sources like coal, nuclear power generation situation, all are based on available materials. So if coal and some non-renewable energy systems is not possible to run. Why? Because due to pollution also some drawbacks will be created with the nuclear reactor or even with the thermal due to smoke and all those things. Pollution will be decreasing day by day, degrading day by day. Hence, that's why people focusing more on renewable energy system, especially clean and green energy like wind and solar energy. And even yesterday also our honorable Prime Minister Sri Narendra Modi garu laid a stone for 30 megawatt generation, hybrid renewable generation in Gujarat. In a almost in 75 acres land, they laid stone for hybrid renewable power generation with 30 megawatts capacity. So that much importance is there for renewable generation since more number of advantages are there. So when we integrate renewable energy generation into the grid, then definitely performance of the grid will be changes. And not only that one, solution of global warming. As I said earlier, so due to existing conventional power generation systems, global warming is going to take place. So for avoiding that, one alternative is renewable generation. And even due to for reducing global warming, we may also use electrical vehicles such that some part of pollution will be reduced with vehicles also. So and customer satisfaction. So all these factors plays vital role to change the performance of the existing grid. Not only that one, few more are there like overcoming difficulties in meter readings. Even in traditional grid, we have analogous electrical meters, so such that accuracy and correctness is missing with the traditional power system. So that one will be overcome by automatic reading systems, the smart meters. So like that. So that's why when you change the meters, then definitely performance will be changed. So how it will be changed means, suppose if a consumer can able to see the consumption pattern daily, then he can think that unwanted loads will be curtailed, and such that especially during peak demand, and such that he will be charged less, and such that he will be saving some amount, such that he can run his organization effectively. So that's why electricity plays a vital role in any organization for getting revenues in any type of business in any organization. So that's why it is also one of the important factor which will change the performance of the existing grid. So similarly, poor efficiency of conventional power generation systems. As I said earlier, even in presently, as of now also, more amount of power will be generated even in India also is coal. So due to poor efficiency of conventional power generation system also, performance of the grid will be changes. Even new business opportunities will be arises. Due to restructuring the power system, new business opportunities are created. That means earlier, few decades, 4 or 5 decades back, people only take the electrical energy for running their day-to-day application needs and for running their organization and for the running the industries. But now people can do business with electricity also. So that's why new opportunities are also created due to restructuring process and aging assets and circuit capacity. So that means due to the aging factors we should consider. Why? Because all our analogous equipments and electrical equipments definitely it may affect with age. So whenever after certain time period we are supposed to replace the electrical equipments, otherwise the efficiency of the power system will be fall down. So that's why definitely performance of the grid will be changes due to the aging assets, aging of the electrical equipments in the power system and security of supply. So thermal constraints. So thermal constraint means due to high amount of heat liberated from the conductors. So constraints will be arranged. So we should take care these constraints. If we are unable to maintain the constraints in the transmission system, definitely performance further varies. And operational constraints like voltage limits or current limits, etc. So these are all the major factors which affect the performance of the existing grid. That's why due to advancement of new technologies in power industry and as well as digital communication system, let us reshape the existing grid and you can make it smarter. That's why we can name it as and it is named as smart grid. And let us see the how smart grid plays vital role in improving the efficiency and performance of the grid. So that here the digital technology that allows two-way communication between the utility and its customers and disseminating the transmission and distribution system information is called smart grid. So that means here by making use of digital communication devices and its technologies, we can make communication from generator to customer and as well as customer to generator. So that means here we smart grid involves two-way communication. Hence, customer can be able to understand not only making communication, so he can also, I mean, smart grid also disseminate the critical information, especially transmission system information will be disseminated. Hence, customers and utility can change their consumption pattern as well as generation pattern based on real-time constraints, real-time conditions. And accordingly, they can make some optimization with respect to generation, with respect to consumption, such that both utility and as well as customer will be benefited with proper dissemination of the information. And customer can have a consumption status and its associate prices through the smart meter whenever they want to examine. So that means whenever a customer want to cross-check how his consumption pattern is involved. So if during critical periods, that means during peak time, definitely electricity prices are high. And at that time, if consumer able to see the consumption pattern and he can predict and he can change his consumption pattern and he can set down the unwanted loads and he can run only critical loads and such that he will be charged during peak demand. So, why? Because during peak demand, prices for electricity is high. So through smart meters, customer can be able to see his consumption pattern and he can change his consumption pattern based on price signals. Hence, which helps to not operate the insignificant loads when the electricity price is more expensive. Smart grid has the potential to play you save money. So not only to change consumption pattern, and you can also save your amount, your money during especially peak demand. So, and he can able to, and he have some clear idea when should he can choose to buy the purchase from the market. So these are the major advantages of smart grid. So communication, two-way communication, and smart through smart meter consumption pattern will be understood by a customer, and such that he can change his consumption pattern. So you just see this smart grid conceptual model. So you just see this. We have a bulk generation, transmission, and distribution, and customer. So dotted lines represents flow of electrical energy among all these entities or all these utilities, and thick line represents secure communication interface. So here smart grid paves path to provide communication from one-to-one organization, such that what is happening from one place to another place and from one utility to another utility and one place to another place will be possible to understand for a customer or an utility or market operators, etc., such that everyone can take care their roles and responsibilities in the power system for optimizing their revenues by maintaining reliable service. So you just see here, service provider is there. He can have control with the customers and market and its operation, such that he can see he can able to maintain balance between generation and demand, such that he can able to improve the reliability of the power system. And smart grid definition. So many people can define many ways, but we just see these two definitions, which are quite common and easy to understand. What is the definition of smart grid? A smart grid is an electric network that can intelligently integrate the actions of all users connected to it, like generators, consumers, and those that do both in order to efficiently deliver sustainable, economic, and secure electricity supplies. So, a smart grid is nothing but a network which can intelligently integrate the actions of all users, especially like generators and consumers, and some people may do both the things. So, in a sustainable and economic and secure way. So, that is the importance of smart grid. And not only that one, you can define in another way. A smart grid employs innovative products and services together with intelligent monitoring, control, communication, and self-healing technologies. So here, innovative products and services together means due to advancement in electric industry, electric power industry, and as well as digital communication system, you can make use their products and you can make use their services, and you can provide and you can monitor and you can control and you can communicate, and you can sometimes you can clear the issues as early as possible due to the all these process. So that is called as smart grid. So let us see the responsibilities of smart grid. So more efficient transmission of electricity. So smart grid always feel responsible to improve the efficient transmission of electricity, and even whenever any disturbances takes place in a system, smart grid can try to restore after clearing the distribution as early as possible, and even reduced operations and management prices for utilities, and finally lower power prices for customers. So if the operations and management prices associated to utilities are reduced, then definitely customers will be charged less for their consumption. And if prices with respect to operations and management is more with respect to utilities, then definitely they can charge more with respect to the consumers. So that's why smart grid paves way to reduce operational and management prices of the utilities, such that customer will be charged less, and such that more number of customers will be make use the electricity for running the day-to-day applications, or even more number of industries also come forward for doing more business. Since why? Because for any business, if anyone want to start, then definitely electricity, without electricity, we can't imagine any business. Maybe it is educational industry, institution, or industries, product industries, or service industries, or commercial, whatever it may be. Without electricity, we can't imagine anything. Any business is not possible. So if business is not possible, then the product based and some facilities in the societies will be evaporated. So that means for creating any business and any competition, electricity plays vital role. And if electricity charge is very less with respect to the consumers, then more number of people will think to start new businesses, such that new opportunities, new employment, new products, and new services will be appeared for the society. So that's why for making better society with better business opportunities, electricity plays vital role. So similarly, reduced peak demand, which also help to lower the electricity prices. So when you manage the peak demand, so when you reduce the peak demand, then definitely electricity price will be less. And how it will be, how smart grid will help to reduce peak demand means, well, definitely smart grid through smart meters, it can disseminate information from hour to hour, such that from time to time it is disseminating what is the price and what is the demand and what is the generation. All the things are disseminating. Based on this, and consumers can predict the electricity prices and such that they can change or curtail unwanted loads or insignificant loads during peak demand, such that they will be charged less. And such that if people are not involved during peak time, then definitely demand uh, will be reduces during peak times, and such that consumers will be charged less. And increased integration of renewable energy generation. So definitely you have to improve renewable energy systems such that system provider can be able to meet the demand with the available generation. Otherwise, if generation is not able to improve, it is very difficult to meet the increasing desires of the people with respect to the electricity. So improved security with reliable operation. So all these are the responsibilities of the smart grid. Let us just understand what are the differences with respect to the existing grid, nothing but traditional grid and as well as smart grid. So in traditional grid, in olden days, we are using electromechanical devices in the grid or in the power system. But whereas in smart grid, now we are using digital communication devices. Hence, due to digital devices, people can understand better the consumption pattern or generation pattern or market conditions, such that they can optimize their generation, optimize their loads, and they can take proper corrective actions before creating any faults or creating any drawbacks to the organization. So, in that way, it is smart grid is more enriched when compared to the traditional grid. Not only that one-way communication in traditional system, and whereas in smart grid we have two-way communication, and even centralized generation. And coming to the smart grid, distributed generation. So in golden days or in few decades back, we have generation is generation, transmission, distribution, all are governed by one person, all are regulated by one person. That's why the deregulated power system comes into picture, where distributed generation also possible to grow now. Hence, losses will be reduced and electricity service to the consumers will be increased with the help of distributed generation. So it's a great idea to start a distributed generation where instead of centralized generation. Numerous advantages are there with respect to the distributed generation. And limited sensors in traditional grid, now sensors throughout. So at each and every critical place, we are keeping sensors and we are tracking information and we are sensing information clearly. And the same thing we are communicating to the utilities and consumers. And definitely with this information, they can take proper actions for running the electricity devices in a right way. And manual monitoring. So in traditional grid, we have manual monitoring. Now it is self-monitoring. So due to the digital and two-way communication and all these advanced equipments, and we can smart grid can sense and can self-monitor the system. And failures and blackouts. So in traditional grid, failures and blackouts will be takes place since if any one failure occurred. So before, why? Because if any failure occurred in a particular place, it is not possible to monitor clearly, and due to time consumption. So that means subsequent failures will also take place before rectifying a particular failure, initial failure. Hence, blackout, power system blackout will be takes place. But whereas due to the smart grid, if any fault is occurred in a power system at any particular part, then immediately it will be identified, and that faulty section will be isolating from the healthy section. Hence, the remaining part will be protected, and such that we can able to avoid or prevent blackouts, power system blackouts. And limited control. And here we have great control. So we have why? Because monitoring is there in smart grid. Hence, it is possible to take proper decisions and to control the situation in a right direction. And in traditional grid, manual restoration. And here in smart grid, you can heal the system immediately by with the help of all these metering devices. So that is nothing but self-healing mechanism is available in smart grid, whereas in traditional grid, it is manual. So due to self-healing and manual, there is a time difference. So for self-healing, it requires very small time to clear the fault. But whereas manual restore means it requires more time, and until you clear the fault, and it is not possible to restore immediately. But whereas due to the self-healing process, immediately we can restore the system into the normal operating characteristics. And it's a smart grid architecture. You just see here, hydro power generation is available, wind is available, solar generation is available, geothermal energy is available, nuclear energy available, thermal energy available, and domestic loads are available, and smart houses are available, electric vehicles are available. So with respect to all things will be coordinated by energy management system. So this is the architecture of smart grid. And let us see what are the various components involved in the smart grid. So major components involved in the smart grid are smart infrastructure, smart communication, smart management, smart protection. So we all know that. So the name itself tells smart infrastructure means what are the. It is further classified into two ways: smart energy system, smart information system. We will see later. So communication system, smart communication system will be possible through smart meters and smart management. So based on the what you call energy management system, with the help of computers and other advanced equipments, we can manage, we can do management techniques in the energy, with respect to the energy, and even smart protection. So whenever any fault will be appear in a system, immediately the sensor can sense the faulty variables, and immediately it can convey to the meters, and such that through the meters and sensors, immediately system operator can understand some fault is taken place, and let us restore, let us separate that healthy section from the faulty section, and immediately you can address the faulty section to clear the fault in that section, and immediately you can give back the power to that section after clearing the disturbance, like that. So protection is also possible. So smart infrastructure may further classified as smart energy meter, smart information system. So smart energy meter is nothing but energy is generated, that is power generation, transmission, and distribution. So in all these three sectors or entities, energy is taking place. So let us apply smart devices, technologies at each and every sector, and we can make those system as a smart, and such that smart in the sense meters or sensors or any computers are for understanding generation pattern and transmission pattern and distribution pattern, and all these things will be equipped with a advanced meters or advanced technology equipments, such that time to time you can track how much energy is generated, how much energy is transmitted, how much energy is distributed to the various customers will be identified, will be monitored. So that's why smart energy system. And smart information system is nothing but smart metering, sensors, phasor measurement units, and information management. Right, smart information. So the evaluation of smart grid lies on not only the advancement of power equipment technology, but also the improvement of sophisticated computer monitoring, analysis, optimization, and control from exclusively central utility locations to the distribution and transmission grids. Smart information subsystem is used to support generation, information, integration, modeling, analysis, and optimization in the context of smart grid. So, in fact, these are responsibilities of the smart grid. That means smart grid should be able to support generation information, integrate renewable generation, and smart grid can able to model all this generation and transmission and distribution analysis, and even smart grid can able to optimize the things with respect to generation, with respect to transmission, and with respect to distribution. So smart information system example is represented with various advanced equipments like smart meter home area network and smart meters, energy storage device, utility equilibrium server, and smart routers. So these are by making use all these advanced equipments or communication equipments, we can make the system smarter. And let us go by important one, smart metering. So smart meter is usually an electrical meter that records consumption in intervals of an hour or less and sends that information directly back to the utility for monitoring and billing purpose. So smart meter is nothing but it's an electrical meter and which can record the consumption intervals and it can send that information back to the utility for monitoring and billing purpose. And automatic meter reading is the technology of automatically collecting the consumption data from the energy metering devices and transfer the data to the central database for billing and troubleshooting and analyzing the system performance. And automated meter infrastructure differs from traditional AMR in that it enables two-way communication with the meter. So when you compare with traditional metering mechanisms, automatic meter infrastructure have two-way communication, but in the traditional way, we have only one-way communication. So that's why customer can unable to see his consumption pattern, and it is difficult to change his consumption pattern during peak demand, such that he will be charged high. But whereas due to the smart metering infrastructure, customer can be able to understand the consumption pattern and peak demand, and such that he can change his consumption pattern and he can be charged less. And even not only automatic meter, you can also see the sensors. Sensor networks are used for monitoring and measurement unit for the grid. So large amount of data and information will be generated from the metering, sensing, and monitoring. And smart grid needs advanced information management. So that means with the help of meters and sensors, smart grid can be able to collect large amount of data and information, and which will be uh, maintained, and that means advanced information management techniques which help handles data modeling, information analysis, integration, and optimization. So here, getting data and information through the meters and sensors is not sufficient. Smart grid must be able to model the data, analyze the information, and integrate and optimize the system with this uh, data. And let us see this grid layout. So smart grid is applied in various organizations like generation, transmission, distribution, even for customers, markets, and even market operations and service providers. So, smart grid is applied with respect to all these areas. Why? Because it is very essential. So, these are the critical. So, in power system, generation, transmission, distribution are traditional, and consumers are also there. But service provider, who is the nothing but independent system operator, who can take care maintaining balance between supply and demand in the market with various market operations. So that's why it is very important to apply smart grid concepts and its devices to all these areas such that you can make power system in a smarter way. So even service customer domain. So let us see this. So that means customer domain means what is the boundary of customer you supposed to understand. So before going to that, this is the domain where electricity is consumed. So customer domain is nothing but in that domain definitely electricity will be consumed by the consumers. And the boundaries of the consumer domains are typically considered to be the utility meter, energy service interface. So the energy service interface provides secure interface between utility and customer interactions. So energy service interface communicates via the advanced metering infrastructure, home area network, local area network. Already I stated in the previous slides. So all these advanced metering infrastructure and home area network and local area network will helps to communicate between consumer domain and as well as utility. So the customer domain is further segmented into various domains, nothing but subdomains based on the energy range. So for if the energy range is less than 20 kilowatts, then the customers is named as residential customers. And if the customers are grouped in between or range in between 20 to 200 kilowatts, then they can be named as that domain is named as commercial customers domain. And if energy range is greater than 200 kilowatts, then we can name it as industrial customer domain. And you just see here customer domain is presented. So you just see this arrow mark is presented. So two sides arrow mark is there. That means you just see service provider, operations, distribution, markets. With respect to all these four, two-way communication is there with respect to customer and service provider and operations and distribution and markets. And one thick line, that is blue line, is represented, which represents internal communication flows between one-to-one domains like what we call with respect to residential, with respect to industrial, and with respect to commercial. In that picture, it is also grouped three layers. One is residential, home, and one more is industrial, and one more is commercial. And in between, not only these type of loads, few more other are there. So like electric vehicle. So electric vehicle may be involved in residential purpose. It is also involved in industrial purpose, and it is also involved in commercial purpose. And like that, it is customer domain is represented in a simple way like this. And you just understand that due to the smart meter and sensors and some more like advanced metering infrastructure, home area network, and local area network. All these things will be possible to communicate in a two-way communication with respect to the service provider, with respect to the operations, distributions, and markets, and all these four with respect to the customer. And market domain is also presented here. You just see here market domain involves. So market is nothing but it involves trading, market operations, and ancillary services, market management, retailing, and aggregation. So with respect to all these six also you have to apply and you have to involve advanced infrastructure and such that you can make market domain as a smarter one. And you just see here, ancillary services means market has to provide not only electricity based on the demand, it also provide ancillary services like frequency support, voltage support, and sometimes reserved support to the different customers based on their requirements. So that is ancillary services. And market operations are nothing but particular market functions, make a particular market function smooth in a smooth way, and of course financial and goods sold clearing, price quotation, schemes, audit, etc. So that means market settlements and its operations must be make smarter, and trading business will also be make smarter, and like that all the things. So all these three are major operations, major responsibilities of the market and market domain. So the markets are where grid assets are brought and sold. Boundaries to the market is nothing but edge of the operations domain where control happens. The domains supplying assets, especially that means market domain is involved with respect to the generation, transmission, ancillary service, and customer domain. So everywhere market domain involvement is there. That's why you have to sense and record the data time to time with respect to all these organizations for taking better market decisions and to improve the efficiency of the market. And various challenges in the market domain has nothing but expanding the capability of aggregators, interoperability across all providers and consumers of market information, managing the growth of retailing and wholesaling of energy, evolving communication mechanisms for prices and energy characteristics between throughout the markets and customers. So these are the various challenges of the market domain. So market domain in a simpler way you can represent like this. So what are the here you just see in this picture blue color that is market management, retailing, aggregator, trading, market operations, ancillary services. All are represented in a circle one. So that is called as market domain. But market domains have two-way communication with other organizations like generation, transmission, distribution, and especially consumers and market operations and service provider. So here service provider can understand the market situations with respect to all these things and he can take the proper decisions. So this is a simple way you can represent market domain. So market domain involved wholesaling, trading, ancillary services, retailing, market management, aggregation, market options, and all operations, and all these things are involved, and all these things will be monitored in a two-way communication with respect to service provider, transmission, distribution, communication, and as well as generation and operations and customers. So service provider. So that means here one to one. So here actually we have generation, transmission, distribution, and customers and market operations and as well as service provider. With respect to all these things, will be varied. So one to one, we have to maintain relations for proper disseminating the information in a two-way communication with respect to each and every entity, such that what is happening at each and every place will be understood by the system operator. So, like that, here system operator or service provider is able to understand customer management, emergencies, emerging services, account management, billing, home management, building management, installation and management, like this. And service provider domain is also represented here. Performance services to support the business process of power system product procedures, distributors, and customers. So here, one important challenge with respect to the service provider is nothing but ISO has to, he has to develop the key infrastructure and standards that will enable a dynamic market-driven ecosystem where protecting critical power infrastructure. So that means dynamic market driven ecosystem means here time to time the load aggregation is changing, the generation aggregator is changing, and demand is changing, and generation capacity is changing, and transmission system is changing. All the things must be tracked by the service provider. That is the greatest challenge of the service provider. Then only you can provide service in an efficient way. So service provider domain is in a simple pictorial representation. Just see here, service provider is with respect to building, customer management, account management, and emerging services. That means unforeseen any problem creates, service provider must be able to meet that service immediately. And similarly, installation and maintenance, building management, home management, and with respect to all these services will be provided by the service provider by monitoring two-way communication with respect to the markets, with respect to the customers, with respect to the market operations. Then only efficient service will be provided to the all entities or customers. And market operation domain. So, what is the operation domain? So, actions in the operation domain are responsible for smooth operation of the power system. So, operation domain. So, in power system, operation must be take forward in a smooth way. So, for taking forward in a smooth way, market operations must be in a transparent way, in a discriminating way with respect to markets and service providers and customers and distributors and transmission and even network operators. And operation domain involves, so operation domain involves major things for monitoring. So supervised network connectivity is required, and for controlling supervised wide area and local automatic or manual control is required, and fault management, fault identification, elimination, and service restoration is required. Analysis for comparing data records. So analysis is very important. So why? Because with the help of smart meters, sensors, and local LAN areas, local area networks, and it collects huge amount of data, and it should be analyzed in a proper way such that unforeseen events will be avoided. And reporting and statistics must be important, achieve on line data, and perform feedback analysis and calculation. That means real-time network calculation actors. So real-time calculations with respect to the voltage, current, power must be important for market operator for disseminating clear information to the participants. And not only that one, trading records and assets and operation planning, maintenance and construction, extension planning, and customer support. And all these blue color represented boxes are very important operations with respect to the operation domain. So these are the various different types of operations must be performed, must be considered through the advanced technological devices like meters, sensors, and LAN, local area network, and with the help of advanced digital communication equipments, we should monitor, we should control, we should analyze, and we should provide services in an efficient way. And bulk generation domain. So similarly, electric generation is the process of creating electricity from other forms of energy, which may vary from chemical composition to nuclear fission following water. And so, as you all know that in golden days, few decades back, more importance is given for the hydel power generation and what you call nuclear, and as well as coal. I mean nothing but thermal generation, etc. And the boundary of bulk generation domain is typically the transmission domain. So generating resources have a boundary with transmission domain. And the bulk generation domain is electrically connected to the transmission domain and shares interfaces with the operations, markets, and transmission domain. So that means generation domain have a boundary with transmission domain electrically, and it can share information to the operations, markets, and transmission domains. And new requirements for the bulk generation domain include greenhouse gas emission controls, increase in renewable generation sources, and provision of storage to manage the variability of renewable generation. So you just see this pictorial representation where different generating resources like gas, coal, nuclear, pump storage, geothermal, biogas, hydel, and wind, solar, etc. So these are the various available generations, and all these generations will have what you call boundary with transmission system electrically. So that's what you mentioned. But not only with transmission system, this generation domain must be able to interact with market and as well as operations for better disseminating the information to the customers. And bulk generation domain can represent like this: asset management, record, protect, measure, control. So whatever the things we are discussing here, the same thing will be represented like this. And similarly transmission system. So for any, especially for power system, transmission is a heart of the system, and it is very important to disseminate transmission information and distribution information to the utilities and as well as consumers in a accurate manner, and that will be possible through smart grid and smart equipments and smart meters, smart sensors, smart LAN network, local area network, and all these things are useful to disseminate and such that why? Because customer doesn't know when his peak demand will be arise, when will be transmission constraints will be arise, when will be congestion in the transmission line will be arise, when will be generators start practicing monopolism or nothing but market power. So market power is an anti-competitive practice used dominant providers, and sometimes accidentally and sometimes incidentally. So that's why disseminating transmission information is very important in the power sector with respect to the utilities and as well as with respect to the consumers especially, and such that people can take proper corrective actions and they will be charged less. Otherwise, monopolism will be once again comes into picture if transmission information is not disseminating properly. A transmission network is typically operated by a regional transmission operator or independent system operator whose primary responsibility is maintain stability on the electric grid by balancing generation with load across the transmission system. So regional transmission operator or independent system operator who is fully responsible to maintain the balance between generation and demand through the transmission network, and energy and supporting ancillary services are procured through the market domains. So ancillary services means frequency regulation or voltage regulation or reactive power supply, etc. All these things will be energy and supporting ancillary services are procured through the market domain, scheduled and operated from the operations domain, and finally delivered through the transmission domain. So that means whether you are procuring ancillary service or energy, you must make use transmission system or domain for transmitting energy from generation to the load centers. So that's why transmission information plays vital role in the electricity industry. Not only transmission, even sometimes we can also consider distribution system information for transmitting and distributing electrical energy from generation to the distribution system. It will be effective only when you disseminate transmission and distribution information effectively to the customers. And in a simple way, you can represent like this: bulk generation is involved in a two-way communication with respect to the transmission system in a circular way where it consists of substation and sag, substation and storage, etc. And even if here aging effects will be considered. If you not able to replace transmission lines based on the aging mechanisms, then transmission line width with respect to the ground will also changes. Hence, sag problems will also create. Hence, performance of the grid will be fall down. So, like this, we're supposed to consider. So that's why disseminating transmission information is important in power industry for maintaining a reliable operation with respect to the power system. And transmission domain, we just see here, it involves with respect to the substation, to storage, and measurement and control. And next one is distribution system, of course, which is also quite similar to the distribution system, but to the transmission system. But the distribution domain patterns are in different ways, like radial, loop, mesh. And the distribution domain is the electrical interconnection between the transmission domain and the customer domain. So definitely distribution will be in between transmission end and customer's end. And distribution domain is structured in different ways like radial, loop, or mesh. In the smart grid distribution domain, will communicate more closely with the operations domain in real time to manage the power system flow associated with a more dynamic markets domain and other environmental and security based factors. So, in a simple way, you can represent pictorially distribution system like this. And of course, we just see the circle one represents distribution domain, where it involves substations, reclosers, and relays, and cap bank, and number of switches, distributed generation. Even in distribution system, distributed generation is also included, and such that this distributed generation reduces transmission line losses. Why? Because this distributed generation is in the load center or very near to the load center, such that no need to transmit distributed energy. Why? Because which is very nearer to the load center, such that losses through the transmission lines will be reduces. So such that it can also meet the peak demand. So whenever demand is more, then with the help of distributed generation, we can meet as much as peak demand. And like that, and you just see arrow marks with respect to two-side arrow marks represents two-way communication with respect to the markets, operations, transmission, and customers with respect to the distribution system. And standards. So standards are written. I hope all of you following, right? Hello. Hello.
Yes, sir.
Yeah. I hope it is visible and audible, right?
Yes, sir. Yes, sir.
Yes. If anyone have doubts, you please interrupt me and ask at any time. I don't have any problem. I will try to rectify even middle of the my presentation also. Well, standards. Coming to the standards. Standards are written agreements containing technical specifications or other precise criteria that may contain rules, guidelines, or definitions of characteristics. So standards ensure adequate for the purpose, compatibility, or interchangeable if necessary. Safer. So standards will be developed based on some safety precautions and some improvement in economic performance and also mutual consent among customers and utilities. And here, various organizations are involved in standardizing the process or National Institute of Standards and Technology and American National Standards Institute, International Electro Technical Communication, and IEEE, Institute of Electrical and Electronics Engineering, and ISO, International Organization for Standardization and International Telecommunication Unit, ITU. So, broad classification with respect to the smart grid standards. So, before introducing something new into a power systems based on some standards and the roles and responsibilities, only you can include those new technologies and new structures into the power systems. And how that will be involved is based on approval from the various standards like IEEE, ISO, ITU, etc. So here it is broadly, smart grid standards are broadly classified with respect to interconnection of distributed energy resources and wide area situation awareness, substation protection and automation, time synchronization, cyber security. So I don't want to go in depth with respect to all these standards. It will be a further one more topic. So I'm just giving brief how what are the various standard organizations involved like this, and what are the broad classifications with respect to the smart grid standards like this. And see, smart grid and microgrid are, in a simple way, smart grid and microgrid are outcomes of restructured power systems, to be frank. Why? Because a restructured power system is created to provide competition and to avoid monopolism and to provide efficient market with respect to the consumers and as well as utilities needs. So these smart grid and microgrid are outcomes of restructured power systems. So why? Because smart grid involve and it can intelligently monitor, control, and analyze the parameters in all the sectors like generation, transmission, distribution, and consumers and market operations, market domain, etc. And such that every utility and customers can change their generation pattern and consumption pattern, and such that optimization with respect to generation and consumption and with respect to operations, efficient operations will be possible. So that is the smart grid. And one more is microgrid. So microgrid is nothing but, in a simple way, it is a localized group of electricity sources and loads that normally operates connected to and synchronized with a traditional centralized grid, but can also disconnect to isolated mode. So that means with the help of microgrid, so microgrid is synchronized with the traditional centralized grid, but sometimes it can also operate by islanding mode also. So that means sometimes whenever situation or environmental problems are occur, then microgrid can separated from the central grid and it can provide supply to the under that microgrid. So microgrids are small electrical distribution systems that connect multiple customers to multiple distributed sources of generation and storage. A microgrid is a scaled down version of the centralized power system. It can generate, distribute, and control power in a small community. That's why some people may use it as localized group of electricity resources and loads. And microgrids are designed to provide uninterrupted power and to balance load demands for a customer with changing power needs. So microgrid may also define the power is generated locally, and its small size make microgrid easier to keep safe both physically and given right control systems from cyber threats. Microgrids do not depend on the traditional grid and can be used to supply critical loads in the case of grid system is disconnected due to the faults. So that means this is one of the important feature of microgrid. That means whenever any fault is happened in a system, then with the help of microgrid, it can separate the faulty section, and for the remaining section, it can give continuous supply through the microgrid. So apart from the central grid. So using sophisticated software, operators can optimize power usage based on demand, utility prices, and other factors. This can save money and reduce carbon dioxide emissions as often required by government regulations. So sometimes if you make use renewable energy sources as microgrid for the local loads surrounding to that renewable generation, then it can reduce pollution. And microgrid structure is represented in a simple way like this: renewable energy, energy storage mechanism, static switches, loads, etc. So micro generation, energy storage system, load and control system, electronic infrastructure, converters. So managing the microgrid. So during outages, the microgrid management system coordinates with the utility grid and enables microgrid owners to become, in essence, mini utilities. So power can be optimized according to availability, efficiency, and cost. So microgrids can, whenever any outages takes place in the system, with the help of microgrid, we can be able to provide continuous supply to the critical loads. So that is very important. And it takes full advantage of renewable energy sources by optimally dispatching stable fossil fuel generation and or battery storage to ensure the grid is always operating in a reliable state. Sometimes, in addition to the renewable energy sources, we can store the excess generation sometimes through the batteries, and you can make use that stored energy whenever energy is not generated with the help of renewable generation sources. Like that also you can maintain reliable operation, and it creates a flexible and scalable system that can adapt as energy infrastructure plans change over time. So that is about how to manage. So managing microgrid means, especially it plays vital role during outages, and it also plays vital role whenever generation is more than the load, and it can be stored in batteries, and that energy will be make use managed whenever the generation with the renewable is not up to the mark. And significance of microgrid. So emergence of smaller generating systems such as PV, wind, fuel cell, microturbines have opened new opportunities for on-site distributed power. So economical challenges, technical advancements, and environmental impacts are now demanding the distributed generation. So the distributed generations have received much attention because it reduces the burden from the conventional power system. So that means even with respect to the capital expenditure, if demand is increases and if you want to place conventional generation plants, it takes more capital investment. Instead of that, if you make use of distributed generation, which are quite near to the load centers, even in terms not only capital expenditure, even transmission lines losses, transmission losses also reduced with respect to the capital investment, with respect to the losses reduced when we make use distributed the generations effectively. So the microgrid looks promising for future aspects. It has the ability to respond to change in the load while decreasing the feeder losses and improving local reliability. So microgrids are low voltage networks or distributed energy system that provides heat and power to a particular area by employing generators and loads. So benefits of microgrid. So whatever the topics we discussed in the significance, they are treated as benefits of the microgrid. So enables grid modernization by integration of multiple smart grid technologies. So that means modernization is involved with the help of multiple smart grid technologies and enhance the integration of distributed and renewable energy sources, facilities integration of combined heat and power, promotes energy efficiency and reduce losses by generation near demand. Already we discussed. Potential to reduce large capital, as I said earlier, capital investment for installing conventional power generation systems is reduced with the help of distributed resources and potential to reduce peak load. And of course, few more are listed here, encourages third party investment in the local grid and power supply, of course, and meets end users' needs, ensure energy supply for critical loads, definitely. So whenever fault occurs, and if traditional grid is unable to supply, then for critical loads we can make supply continuous supply with the help of microgrid. And power quality and reliability control locally and promotes demand side management and load leveling, promotes community energy independence and allows for community involvement in electricity supply. Designed to meet local needs and increase customer participations. All these are benefits due to the microgrid. So definitely microgrid support uh, a lot with the traditional grid and traditional generation and applications of microgrid. So microgrids can meet the needs of a wide range of applications in commercial, industrial, and institutional levels. Large microgrid applications include communities ranging from neighborhood to small towns to military bases. Another largely untapped application is the off-grid area of the world where online. So that means for some areas it is not possible to provide supply through the conventional grid, and for those people we can make microgrid with the help of distributed generators and we can provide continuous supply for critical areas especially like hospitals, research centers and government offices, etc. And wide area monitoring system. So this is one more technology by making use satellite signals. So that means it's a collective technology to monitor power system dynamics in real time, identify system stability related weakness, and helps to design and implement countermeasures. So wide area monitoring system uses a global positioning system satellite signal to time synchronize from phasor measurement units. So by with the help of global positioning system satellite signal time synchronized from phasor measurement units at important nodes in the power system sends real-time phasor data to a central node. So for capturing critical data, here global positioning system satellite signals are used through phasor measurement units, and it can capture the data and it can send critical information to the control center such that proper actions will be taken place by the operator. So the acquired phasor data provide dynamic information on power systems which help operators to initiate corrective actions to enhance the power system reliability. So you just see the goals and benefits of the wide area monitoring system. So major goals of the wide area monitoring system are nothing but real-time monitoring, post disturbance analysis. So you have to monitor what is happening time to time in a real time, and after disturbance clearance, you're supposed to understand that with the help of data, you're supposed to analyze uh, what, what actions are to be taken for the next time. So adaptive protection, power system restoration. So these are the major goals of the wide area monitoring system. And you just see here controllable and protecting device measurement and status data, and which is two-way communication through data storage, data alignment, and concentration monitoring, displaying near real-time dynamics, security assessment, automation, and through smart operator decision support and smart operator control actions back to the network. So like this, you're supposed to know. So the same goals are presented here. So one is real-time monitoring. So to provide operators with real-time knowledge of system conditions. So what are the benefits if we monitor real-time data? So which helps to improve calculation for real-time path flows and optimal dispatch. Not only that one, it also provides actual limitations on the system instead of the conservative ones from offline calculations. And second one is post disturbance analysis. So to reconstruct the sequence of events after disturbance has occurred. So easier to understand sequence of events, what type of faults will be takes place and what type of events will be takes place, and when using synchronized data from phasor measurement unit. And next one, next adaptive protection. So you're supposed to provide protection with the help of wide area monitoring system, and which helps easier to understand sequence of events when using synchronized data from phasor measurement unit. And so adaptive protection setting to avoid cascading outage and backup protection is improved. And assist system operator during restoration with data from phasor measurement unit. So the benefit with respect of based on assisting system operator have more confidence during restoration, reduce chance of recurrence of system outage, and time needed for system restoration. And components of wide area monitoring system. Major components, as I said earlier, phasor measurement unit can capture the data through satellites, and phasor data concentrator, global positioning system, communication channel, visualization and analysis tools, wide areas situational awareness system, wide area protection and control. So all these are major components of the wide area monitoring system. And with the help of this, information is captured at real-time conditions, and it is analyzed after post disturbance, and it will be considered a sequence of units with the help of that analysis, and later protection will be provided. And similarly, the process of wide area monitoring system involves data acquisition, data transmitting, data processing. These are the three critical steps which used by the wide area monitoring system by using phasor measurement units. And data resources of wide area monitoring system. So operational data and non-operational data. So operational data is nothing but continuous stream of data and measurement of voltages, currents, phasor, and breaker status measured by intelligent devices, especially SCADA, supervisory control and data acquisition, and synchronized phasor measurement unit. So SCADA and measurement system plays vital role to capture the operational data, and non-operational data will be collected periodically by a specific time interval and consisting of records of multiple events like a series of faults, power fluctuations, disturbances, and lightning strikes. So, example: digital fault recorder, digital protective relay, and circuit breaker. So various applications of wide area monitoring systems are involved are applied to generation, transmission, and distribution with respect to all these things. So with respect to generation, so with respect to generator operation status monitoring, transient angle stability. With respect to transmission, load flow, optimal power flow, and load forecast. And with respect to distribution, substation automation, feeder automation, consumer side automation. So let us use SCADA and phasor measurement unit. So phasor measurement unit have more advantages when compared to SCADA. So when we talk about various attributes like the resolution, measured quantities, time synchronized, total output channels, and in all ways, phasor measurement unit gives better information and quick information and more information. With respect to resolution, one sample every 2 to 4 seconds, but whereas phasor measurement unit can capture 10 to 16 samples per second, so that is with respect to dynamic and transient observability and measured quantities only in terms of magnitude, but whereas phasor measurement unit can also measure not only magnitude, it can also measure phase angle. And time synchronization is not possible with respect to SCADA, whereas phasor measurement unit can be able to maintain time synchronization. And even output channels are around 100 plus analog and digital with respect to SCADA, whereas phasor measurement unit, 10 phasors, 16 plus digital, 16 analogs, like that we have. And focus local monitoring and control. But here, with respect to phasor measurement unit, focus on wide area monitoring and control. So more amount of area, so large amount of area is monitored and controlled, whereas SCADA can able to restrict only local areas. So these are the advantages of pulse width, phasor measurement units with respect to the wide area monitoring system. So let us, these are the topics I want to discuss. And coming to the summary, it is understood that smart grid have better advantages and features when compared with traditional grid. And smart grid conceptual model, responsibilities, components, smart information, smart meters, and sensors are discussed. Grid layout, customer domain, market domain, service provider, and operation domain, transmission domain, generation domain, distribution domain, and various standards are also discussed. Microgrid and its structure, benefit, applications are also presented. Wide area monitoring system and its components, goals, benefits, and applications are discussed. So these are the topics we discussed, and it shows that smart grid and microgrid are outcomes of restructured power systems, and these two plays vital role to disseminate information to the customers and utilities time to time, such that utilities and customers can take proper optimization with respect to generation and with respect to consumption and with respect to some operations for improving and maintaining reliable operation in a power system. So these are the things. With this, my lecture is completed, and if anyone have any doubts, please ask me.
So thank you, sir.
Yeah, thank you.
Participants, if you have any queries, please post the queries or we may ask directly.
Yes, any questions?
Good afternoon, sir.
Hello.
Yeah.
Hello, good
Hello, sir.
afternoon,
Good
sir.
afternoon. Please tell me, sir.
Sir, your presentation is very nice, very informative.
Thank you, sir.
Really very good information we have received. Sir, regarding the smart grid, I have one, you can say, doubt.
Yeah,
As the
please.
tariff of electricity is increasing day by day,
Yeah.
and though we are approaching to the smart grid, so why
Yes.
smart grid is not helping in reducing the tariff of electricity? Do you have any idea about that? Please comment.
Yes, sir. Definitely. So, smart grid definitely helps to reduce the tariffs. So why? Because a consumer, so with the help of smart grid, with the advanced digital equipments like smart meters, sensors, and various networks and computer operators, all these helps to disseminate information time to time, such that such that consumer can understand his consumption pattern, and during whenever peak demand arises, and he can change his consumption pattern, and he can set down insignificant loads and unwanted loads during peak time, such that he will be charged less. I hope.
Definitely, sir. Sir, I do understand. Sir,
Yes,
my
sir.
question is that actually means considering the general public or considering all the consumers, not to any particular special consumers, as renewable tariff rate are very less,
Yes,
but general tariff rate of electricity is very high. And
yes,
as
sir.
we are migrating to a smart grid, micro grid, so whether it has to be used, it has to be make such arrangement to reduce such prices. So, what is your opinion on that? That I want to know.
So, with respect to you are talking, you are asking only tariff, sir.
Yeah. So I'm asking that as the rate of tariff is increasing day by day, and we
Okay.
are migrating to a smart grid, advancement of the grid,
Yes, sir.
but that
Sir,
advancement of grid is not helping the common people by reducing the tariff. So, what are
understood.
the lacunae in that? That I am asking, sir.
Sir, one major reason is increasing population day by day. So, creating renewable generations, distributed generations, and traditional power generations are not able to meet the increasing demand day by day, such that
Yes.
tariff rates are also increasing. If the generation, available generation, is able to meet the demand, then definitely tariffs will be comes down. But generation, available generation, and like with respect to conventional power plants or distributed generations or with the smart metering. So available generation is, to be frank, which is not able to meet the future increased demand, and even present also demand is more when compared to the available generation. So uh, for maintaining balance between generation and demand, we are now, in addition to the including and integration renewable generation, we are also providing smart grid technologies such that people can use only critical loads during peak time, such that some part of generation will be provided to the real people who really require load.
Yeah,
So that
actually,
means,
okay.
so major problem is only population. Population is day by day increases, and available resources are not able to meet the demand, such that tariffs are increasing. Why? Because more, whenever population increases, then definitely people doesn't care about the tariff rates. Some people, some organizations, they really required, and they can pay any rate. So irrespective of whether high or low, they don't bother. They want to run their critical loads. Then only they can maintain the businesses in a proper way. Otherwise, they will get huge losses. So those people can never bother. So that's why rates are increasing, and major reason is population. So more number of business businesses, industry businesses, domestic purposes, agricultural purposes, commercial purposes, everywhere, whenever population increases and all these sectors and all these business activities with respect to agriculture, with respect to commercial, with respect to domestic, with respect to industrial, and with respect to institutional, everywhere it is increasing and available energy is not able to meeting the demand. Hence, people always, definitely it's a competitive market and people used to do business with electricity also. So that's why tariff rates are quite higher than the available. So one major reason I support is increasing population day by day. Hence, we are unable to meet the generation with respect to the demand. So that's why, but with the help of these smart devices, few customers can track their consumption pattern and can they reduce their consumption pattern based on curtailing the insufficient or insignificant loads, such that little bit they are charging less with respect to the tariffs. I
Exactly.
hope I
Exactly. Thank
answered
you.
it. Yes.
Yes, thank you, sir. Very nice. I am impressed by your presentation also. So, if possible, sir, can you share your email address with us? If you have
Yes.
any query in the future, we can contact you directly, sir.
Sure, sir. Definitely, sir. So actually, I forgot to mention slide in this one.
Okay.
I will share my.
Yes, sir.
Is
Please
it
share your email address and your mobile contact number so that in our research process we will get your guidance.
Sir, we will share at the last, sir. At the last of the all the sessions, we will share all the details of the resource persons.
Okay,
So
thank you,
at
ma'am.
that time, yes, sir. We'll share the PPTs which we have received from the resource persons and their details also, sir.
Are you able to are you able to see my screen right now?
Yeah, yes, sir. Definitely. Yes.
Sir, here I typed my email ID. You please see this one, sir.
Okay, sir. Yeah, sir.
So jsreenivaslu.triply@jnua.ac.in and my mobile number is 988-5959-798.
Okay. Thank you, sir. I will contact you, sir, in the future when I need your help, sir.
Please,
Thank you, sir.
please,
Thank you very much.
please. Thank you very much. Yes, sir. Any more questions? Yes.
I think they have posted as nice session, sir.
Thank you, madam. Right. On the behalf of at this junction, I thank. Yes. Any question is there?
Is there any question from anyone? You can unmute yourself and you can ask the questions. Dear participants, if you have any questions, you can ask, sir, directly.
Okay. I hope they don't have any questions, madam.
Okay,
So at this point of junction, I thank Dr. Sudhir Kasa for giving me this opportunity. And I also thank all the Lakshmi madam and Deepthi for introducing me to and coordinating with me during my presentation. And I thank Sudhakar sir, Professor Sudhakar sir, Principal of SV Engineering College, for giving me this opportunity. Thank you very much.
Thank you, sir. It's our privilege to have you, sir, because you have continuously supported for 2 STTPs.
Yes,
we feel privileged to have you, sir. Thank you.
Thank you, madam. So can I quit, madam?
1 minute, sir.
Yeah, please.
Sudhir, sir.
Ma'am, sir,
Yes, sir, please.
Sir, thank you so much, sir. From my bottom of my heart, I really thank you, sir, for delivering 3 sessions. It's like a boon for us, sir, to have you, and as a well-wisher, sir. In future also, we need your help, sir.
And
thank you so much, sir.
I also thank you, Sudhir, for giving me this opportunity and to explore my knowledge with various eminent teachers in the group. Thank you very much.
It's our pleasure, sir. Thank you, sir.
Thank you. So can I quit, Sudhir?
Yes, sir. Yes, sir.
On behalf of Triple Department and SP colleges, we thank you a lot, sir, for your detailed and elaborative session on smart grids, microgrids and wide area monitoring, etc., sir. We expect
you.
the same from you, sir, for our
Sure.
future programs also, sir. Thanks a lot for your availability, sir.
Thank you, madam. Thank you very much.
Even in spite of your busy schedule, you have allotted 3 sessions for us. For that, we have to thank you, sir. On behalf of our department, and we have to thank you, sir. Thank you so much.
Thank you, madam. Thank you, Sudhir, sir. Right, sir.
Thank you, sir.
Participants, please submit the feedback link. We have shared the day 2, session 2 link in the chat box. Please submit the feedback link.
So, sir, can I quit the
Yes, sir.
session?
Yes, sir.
Thank you. Thank you, madam.
Thank you, sir. Dear participants, it's mandatory to submit the feedback link. So please submit the feedback. Again, we will start the session tomorrow by sharply at 10 o'clock. So please submit the feedback link and you may leave. Thank you.